Welcome to Configuring ScreenOS Firewalls. This is our session on configuring route-based VPNs, the third in the VPN series. In our first session on VPNs, we went over the VPN concepts and how the IPsec VPN standards work. In the second session, we discussed standards-based policy VPNs and how those get implemented in ScreenOS. In this section, we're going to talk about route-based VPNs. Route-based VPNs are something that Juniper offers that are not available on every VPN implementation, and they allow you to treat a VPN connection as if it's any other network connection using standard routing protocols and standard policies rather than tunneling policies. So the objectives then for this session are to understand what the concept is for a route-based VPN, to be able to configure the additional parameters that you need in order to create a route-based VPN. These are the tunnel interface, either IP unnumbered or using a specific address, how you handle proxy ID settings when you're doing a route-based VPN, because you will not be using the tunneling options and the generated proxy IDs. And we're also going to talk about the VPN monitoring option that's available for VPN gateways and how to use that to keep tunnels up at all times. Then we're going to talk about how you verify then the operations that a route-based VPN is up, active, and passing traffic. So this divides out into three sections. First, we're going to talk about the concepts that are involved and the terminology for route-based VPNs, then the actual configuration, and then finally the verification operations. A route-based VPN is optional you can always use policy-based VPNs, and the route-based VPN is a way to create the connections independent from the VPN policy itself. As a result, the actual policy that permits the traffic is not necessarily associated specifically with tunneling operation. The tunneling operation is independent of policy and routing. So it's not even necessary to have a policy. If you were to configure the remote site and the local site to be both in the same zone, and therefore say they're both in the trust zone, and intra-zone blocking is not turned on for the trust zone, then no policy would need to be configured at all on the device, because the traffic is transiting from trust to trust, no policy required, it can go. So the policy can be optional, and because the policy is not required per tunnel, your policies also become more flexible. You can write policies based on the types of traffic and the zones of the traffic independent of the physical connection. So you no longer have to have a policy for each of these tunneling connections. The policies can be written for your web server policies, for your computer access policies, independent of whether or not that computer is across a local LAN link, a frame relay link, or a VPN tunnel link. The same policy, the identical line, the same policy applies to all that traffic, because policy is now independent of routing. With a traditional policy-based VPN, the policy is also the route. So routing and policy are intimately tied together in the same object. By creating route-based VPNs, we are separating policy from routing, and the physical connection is different than the policy that permits the traffic or the routing on how we get there. A tunnel interface is necessary, so this is an additional configuration object that you'll need. Instead of this traffic being done by gateway, we use a virtual interface rather than a physical interface that's known as a tunnel interface. And then because this tunnel interface then abstracts out the connection for us, we are able to separate the routing from the policies, and the connection is independent of both. You can you can create a single tunnel interface and connect multiple VPNs to it, like a point-to-multipoint. And you can put this interface then in any zone. So you have the flexibility of creating zones per remote site, putting remote sites in the same zone as your local site, or doing a trust to untrust relationship between them. The interface that is the tunnel interface can be in whatever zone you want to design your transiting rules or your policy rules by. And this interface can also have its own IP address, which gives it even more flexibility. It does not have to borrow or be associated unnumbered with an IP address of an existing physical interface. So once we set things up this way, routing then determines whether or not we use the tunnel and not a policy. So you can use static routes and point them at particular interfaces like the tunnel interfaces, or you can deploy OSPF, BGP, or other routing protocols and set up neighbor relationships across these tunnels so that routes can be automatically distributed. Routing is now independent of the policies created making tunnels. So this separates entirely the delivery of packets from the permissions on packets. Tunnels, VPN tunnels, become like every other connection on your firewall. There is no other connection on your firewall forces you to have your routing and your security policy done in the same object. Route-based VPNs bring that same functionality to IPsec VPNs, again separating delivery from permissions. And finally, this does support then dynamic routing protocols. On your typical policy-based IPsec VPN, because the routing is part of the policy, it's setting up this static route right on this this firewall device, pointing it down this tunnel, and everything's based on what those proxy IDs are, and it's all statically configured. Because we've separated delivery from permissions, we can create a neighbor relationship. We can place this tunnel into OSPF. We can create a neighbor relationship between two firewalls across this route-based VPN. And routing now no longer has to be statically configured everywhere. It can be distributed in your dynamic routing protocol. So let's take a look at a standard network diagram. This is a two-office situation here. We have Tokyo on the left and Paris on the right. And you see all the interfaces that are created for both of these offices. The top, Tokyo has a trust zone locally and everything else is untrust, and the same for Paris. Paris has the trust zone on the local LAN and untrust everything out further. So our tunnel interfaces in both these cases, we have a tunnel.1 interface in Tokyo in the untrust zone. We have an outgoing interface in the untrust zone, and we have an external router in the untrust zone. In Paris office, we have a tunnel.2 interface, an outgoing interface, and an Ethernet router in the untrust zone. So we have all these setups to allow us to do a trust to untrust VPN route-based tunnel, and the interfaces necessary for this communication to occur. Now, there is one issue with this particular diagram, in that these two administrators have created their architecture on each side, but the tunnel interfaces that are going to connect to each other do need to be in the same subnet. So we have two different subnets here in this case. We've got 10.1.2.1 and 10.2.1.1. So one of these administrators is going to have to change their tunnel interface to be in the same subnet as the other to complete this operation. Let's talk a little bit about the concept of the tunnel interfaces. Tunnel interfaces can be bound to any zone. So in our previous diagram, we were putting our tunnel interfaces with an IP address into the untrust zone. Whatever zone you place this into, then it's going to follow the packet flow rules. So when a packet arrives or departs, that's the zone that the policy is going to need to be written for, either as the destination or the source of it. So that can be associated, as we mentioned earlier, with the trust zone. So if you put these tunnel interfaces into your trust zone on both sides, then it's intra-zone traffic, which is permitted. So you actually don't need a policy then. But zone binding then occurs at the interface level, and the tunnel interface is like every other interface that we learned about in ScreenOS. It can be placed into any zone that you want to for your security zone design. Now your interfaces, multiple interfaces will have a number. So we got tunnel.1, tunnel.2, etc. There is a limit of the number of tunnel interfaces you can create on each platform. So you'll have to check your spec sheet for your device to see what the maximum number of tunnel interfaces you can create for each device. The IP address on the interface can either be unnumbered, meaning it's going to attach itself to a parent interface, and then you have to select which parent is going to be the parent interface, or it can be a fixed IP address, as we saw in the previous slide. So if it's using a parent interface, you can attach it to your gateway, Ethernet 00, and then therefore it's going to be in the gateway zone, which is untrust. Or you can unnumbered and attach it to your internal interface, your B group 0 in trust, or your whatever Ethernet interface is assigned to the trust zone. So when it's unnumbered, it's going to borrow the IP address and zone from whatever parent interface the tunnel interface is associated with. So looking at the fixed address objects, you're going to select an IP address and a mask as it shows on this. The Tokyo office is 10.1.2.1/24, and the Paris office is 10.2.1.1/24. When you create this IP address for the interface, the same rules apply with every interface on the device, so you can't overlap with an existing interface on the same device. So we could not put the Tokyo office tunnel interface as 10.1.1.2. That's going to be a subnet conflict, and by default, ScreenOS wants every interface to have an independent subnet. If you want to put them together, you would put them into a bridge group. You can override that setting, but that can cause routing problems. So you generally want to stick with no overlapping subnets. You can use, if you have a fixed address, you can use the MIPS and the DIPS for address translation on your tunnels. So now this brings the flexibility of NATing and port address translation to tunnels. And interfaces that are going to connect to each other on a tunnel have to be in the same subnet. So one of our administrators here in Paris and Tokyo is going to need to change the IP address of their tunnel interface in order to complete creating this route-based VPN, because tunnel.1 in Tokyo is not in the same subnet as tunnel.2 in Paris. So one of these two guys is going to admins is going to have to make that change in order to complete this tunnel configuration. Unnumbered tunnels, you don't have to create a subnet then for them, and they can just be attached to an interface. They will be associated with an interface that has its own IP address. No address translation will be able to be used when you have an unnumbered interface, and obviously if they're unnumbered, they don't need to be configured in the same subnet with each other. So you also then don't have to keep track of your intercommunication subnets if you use unnumbered. So this can be a simpler method of creating these tunnel arrangements to not have IP addresses explicitly configured on each of these virtual interfaces. Okay, so let's look at how the configuration actually works and where these tunnel objects come in. We're going to go through the process of creating a route-based VPN, and you'll see most of the steps here are the same as policy VPN. It'll just be a few differences. To configure a route-based VPN, we are going to need to create the tunnel interface that we're going to need for the configuration in advance. We will then create the gateway in the same way that we created the remote gateway object for a policy VPN. We are going to create our IKE VPN object under AutoKey IKE, but there will be some additional parameters required for that. We will need to configure routing so that the remote network can be directed to the correct interface. In this case, we're going to use static routing. Then we're going to create any policies that are needed to pass the traffic. They do not have to use the tunnel object. Matter of fact, they can't use the tunnel object. They're strictly standard policies. And now, once you've created this route-based VPN, you go back to the policy lesson and you're strictly using permit and NAT as necessary. No other special configurations in the policies. It's just what zone is it coming from, what zone is it going to, what IP addresses and protocols are being permitted. There is no difference in the policy creation. You go back to the policy lesson, you go back to the network address translation lesson, and you treat this connection like any other connected or remote network on your device. No tunneling option required. Okay, to create the tunnel interface, we're going to go to the interfaces area, set interface tunnel.1, put it in a zone, set interface tunnel.1, assign it to an IP address. Just like Ethernet 00, B group, any other interface, exactly the same commands. This is also under interfaces in the web area, so you're going to select the pull down list to say tunnel interface and create a new one, and you are presented with placing it into a zone, giving it an IP address, or making it an unnumbered one and telling it which interface the tunnel will be associated with. So the tunnel interface is just like every other interface on the device and configured using exactly the same commands. Now we go to our standard VPN creation. We're going to create our IKE gateway, and this works exactly the same way it does for the policy-based VPNs, which means we set IKE gateway, give it a name, the remote address for IP or DNS, the outgoing interface that it can be reached with, the pre-shared key, shared secret in this case, and our security level. Just like in the previous lesson, exactly the same process, exactly the same place on the web. So we create the name of the gateway, the IP address, and we go in and enter the pre-shared key and choose our proposal security level or the customized one. So this step 2, has no difference at all between policy and route-based VPN. The gateways are identical. Now there are some differences in IKE, but this part of the process is the same. We're going to go in and create the IKE VPN. We're going to give it a name. We're going to associate it with a gateway, and we're going to give it a security level. So the fundamental configuration of your phase 2 is going to be exactly the same as what we did for the policy-based VPN, where you give it a name, associate it with a gateway, and assign a proposal to this negotiation. So far we've done everything exactly like a policy-based VPN in creating the phase 2 configuration. So the second phase, though, is the first difference. We are going to bind this phase 2 to a tunnel interface instead of none. So in IKE command line, you're going to go set VPN, name VPN, bind interface tunnel.1. It's a separate command line. It's not something you can tag on to the creation process. And on your advanced tab in creating the AutoKey IKE, this is another section available to you. By default, for a policy-based VPN, this is bind to none. For a route-based VPN, you choose tunnel interface option on the left and pull down which of the tunnels that are configured that you're going to associate this with. This is a required configuration for a route-based VPN. It has to be bound to that tunnel interface, and this is the first difference then with route-based VPNs to policy-based VPNs. Proxy IDs are handled differently on route-based VPNs. If you don't do anything, which is the preferred method for a route-based VPN, it will use as its proxy ID 0.0.0.0.0/0, meaning any network to any network can be connected across this VPN. If you're connecting a route-based VPN between two Juniper devices, this is what you should use. This means absolutely any traffic can be directed up and down this tunnel, and it's totally at the discretion of your configured routing operations what goes there, and it never has to be updated or changed. Remember when we talked about proxy IDs, these create essentially access control list restrictions between the two devices on this VPN tunnel. So this is the most proxy IDs establish the most that will be allowed to transit between them. If we leave them at 0.0.0.0/0, that means anything can be done, and it's just up to our routing and policy configuration to direct the traffic and permit the traffic. You can, however, restrict this if you want, and you can use route-based VPNs on a Juniper device connecting to policy VPNs on a remote device. If you do that, then the proxy IDs have to match, or you'll get that proxy ID mismatch error, and many of them won't accept 0.0.0.0/0 as a proxy ID because of overlaps. So then you would have to explicitly configure proxy IDs. In your IKE VPN, you would set your proxy ID local IP and remote IP in this fashion on the command line. Set VPN, the name of the VPN, the proxy ID, local IP address, and the remote IP address, and the any is the service here at the end of it. So on the web interface, there's this section on the web. This is the interface for version 6.2 and earlier. In version 6.2 and earlier, you can have only one configured proxy ID pair. So this is a restriction of the software. If you need to be able to send multiple proxy ID pairs, then you'll need to upgrade to version 6.3 for your route-based VPN. In 6.3, proxy ID becomes a separate configuration option then under your AutoKey IKE. Instead of editing or hitting New Advanced, there's a separate link there for proxy ID, and then you can add multiple proxy IDs in 6.3. They'll be added in the same fashion, and in 6.3 they can be added based on address book entries if you desire. So again, if you're doing route-based VPNs, the considered best practice is to leave this blank, have having the Juniper device on each side. Leaving this blank takes all your proxy IDs to 0.0.0.0/0, and then your routing configuration and your policy configuration is what drives how traffic gets directed down this tunnel and what is permitted down this tunnel, and there's no configuration required here. An optional configuration you have is VPN monitor. This can also be used with policy-based VPNs. It is a feature that allows you to keep a tunnel alive even if there's no traffic being generated on either side of the tunnel. This allows you to select a interface and an IP address to ping, and allows you to rekey and optimize the VPN so that it basically keeps it alive. In other VPNs software, you will see these options as the keep alive option. In this world, you can actually specify an IP address and a source interface to send a ping across, or you can just use the optimized and rekeys and the defaults as a standard keep alive. In the web interface, this is on the advanced tab of your AutoKey, and you fill it in here to turn on the monitor. Select the specific interface and IP address that you want to ping, and whether or not you want to do the optimize and rekey in the tunnel to keep it alive all the time. As I said, this feature can be used with policy-based VPN as well. When you set up this type of keep alive or VPN monitor, you want to make sure that you only configure it on one side of a VPN. You want the way the standard for VPN works is there's an initiator and a responder. If both sides have this configured, either the keep alive on on another product and this on Juniper, they both want to play initiator role. And if they start close enough to each other at the same time, neither of them becomes the responder. They're both sitting there trying to be the initiator, and neither of them will respond to the other. So when you design your VPN network, you want to make sure only one side of each pair is an initiator configured this way if you're keeping the tunnels up and alive. You don't want to put your keep alives on both sides of the same tunnels. You can end up with a situation where the negotiation's never complete, even though the rest of the configuration matches. Okay, now we have our basic phase 1 and phase 2 up. Instead of creating a policy that's going to create the routing and the allowing the traffic, we're separating these now. So we're going to do routing first, and in this case we're going to create a static route using the same commands we learned in the previous lessons. So set VR trust route 10.1.1.10/24, and out in this case you would change you would direct this to your tunnel interface, tunnel.1, and the gateway would be the IP address on the remote site that's going to accept this traffic, or you can leave the gateway blank if it can be accepted directly by ARPing across that link. In the web interface, this is still a destination route, and you would just change that interface from Ethernet 0.1 to your tunnel interface. And again, you can leave the gateway IP address blank and send it just to the interface, or you can direct it specifically to the IP address of the remote site router that's going to accept this traffic. So the tunnel interface gets used as the gateway in creating these static routes. As we mentioned before, you don't have to use static routing. This is one of the advantages of route-based VPNs. So you can create a neighbor relationship across this VPN tunnel. You can place this tunnel interface into your BGP or OSPF network and create the neighbor relationship across this tunnel. Those functions are gone over in the advanced course. Okay, and then policies. Policies you create exactly the same way you do in the policy lesson. In this case, we're going to have our trust to untrust zones. So the Tokyo office is going to create a trust at network object at 10.1.1.1/24, an untrust object at 10.2.2.5, and it's going to create a policy from trust to untrust to permit that traffic, and it's going to create the reverse policy to permit the reverse traffic. Or it can be narrow. You don't have to connect the whole network. You can just allow access to, say, there's a server in Paris that Tokyo wants, but they don't want them to connect to workstations. You can create a policy just to that server. And anything you don't create is denied, because this is a trust to untrust transit. Cross zones has to have a policy. Same way in reverse. So here now we've basically gone to policy design. You get to design your policy connections independent of the tunnel action. You're going to be using permit and deny, not tunnel, and you're going to connect across this VPN tunnel as if it were a network link of any other kind. And the zones that you're transiting is based on the zones of the tunnel interface. So in this case, we've placed our tunnel interfaces into the untrust zone. So therefore, our policies are trust to untrust across this network, or untrust to trust back from the other side. You can make these policies then as specific or general as you want, and you can have them designed in whatever model you want. You can model your policies based on protocols. You can put groups of servers together. You can do all of the things you would normally do in policy creation to organize your security rule set, independent of how you arrive at that server or network. And the services can be handled in the same way. You don't have to do this broad connection of entire network to entire network on any service. You can have independent policies, service by service, host by host, network by network, and design your policies however they are. Go back to the policy creation lesson and do your security design independent of the method that you're using to connect to that resource. Okay, so route-based VPN has been created, policies designed and up, routing is in place, all that's done. We want to make sure that it works. We're going to verify the operations of this using ping or service checks, exactly like we did on the previous one. If we have a problem with the VPN, we're going to see these same phase 1 errors that we see on a policy-based VPN. Does it have an unrecognized peer, which means the gateway IP address is not correctly configured? Is there a proposal mismatch? Are one of these parameters for the Diffie-Hellman group or the security mismatching? If the initiator if the initiator gets a transmission timeout, that's the usual message we see in the event log for this. If the responder says rejected the proposal, that means we got to go look at that proposal configuration in phase 1 and make sure that all the elements are the same. In the phase 2 errors, these are exactly the same as well. Is there a proposal mismatch in phase 2? The initiator will say no proposal chosen, and the responder will say it rejected the proposal. So these are the exact same error messages we're going to get from that we discussed in policy-based VPNs. It's still a phase 1 and a phase 2 negotiation. The same errors can occur in phase 1 and phase 2, and you're going to look for these errors in the event log. Proxy ID mismatched. We talked previously. Now the proxy ID is going to come from the configuration on the AutoKey IKE, the phase 2 object. You're going to leave that blank and send 0.0.0.0/0 on both sides, so they should match. If you need to configure that, then it does need to match, and you will see a proxy ID mismatch error if they aren't. And if you need multiple proxy IDs on a route-based VPN, you're going to need to upgrade to the 6.3 version of ScreenOS, because the 6.2 and earlier, you can only configure a single proxy ID pair. On the proxy ID message, you're going to see the responder will say no policy exists for the proxy ID received, and that's how you're going to know that these are mismatched. Common errors: proxy ID mismatched, the policy-based NAT on the unnumbered interfaces is not going to work. So you will be able to configure that, but it's not going to work. So you need to make sure if you're going to need NAT operations, you're going to need to have numbered interfaces. If you are not careful about where you bind your tunnel, your policies won't work. So make sure you're putting the tunnel into the zone your policy architecture is expecting the traffic to be in. You can see this generally if you look at the policy. You think it should be hitting a policy and you don't see any traffic logging there, therefore it's not hitting the policy. Therefore, you know, the one of the reasons the policy wouldn't apply would be the zone to zone relationship is not correct. And routing problems. You can do some trace routes, make sure that your static routes and your distributed routes are actually pointing to the correct tunnel interfaces. You can go back to the routing lesson we had earlier, you know, getting the route for the IP address to make sure that it's being directed to the right place. Look at the routing table, because you're no longer forcing routes based on a policy configuration. You have to do routing troubleshooting, standard routing troubleshooting, IP, just as if it's any other network link. And intrazone blocking. So if you have tunnel interfaces that are all in the untrust zone, and you know, perhaps you have two remote sites trying to communicate with each other across that tunnel, by default, untrust zone has intra-zone blocking turned on. So you got to make sure there's an untrust to untrust policy to allow that traffic to occur. The same troubleshooting tools are available. You're going to use the event log to get your phase 1 and phase 2 errors that we mentioned earlier. You're going to use your get IKE cookie to see what phase 1 associations are in place. You can use your debug flow to follow the trace of a packet, what policies it's hitting, and how it's being routed through the device, and you're going to use your debug IKE. In phase 2, you can see your SA database, and if it's there or not, you're going to get your unset IKE policy checking if you want to loosen up the restrictions on this. So our policy-based VPNs share a lot in common with route-based VPNs, but there are some differences. So you should now understand how the concept of the route-based VPN separates routing and permissions from the negotiations of the tunnel itself, and moves routing and permissions into the standard policy engine and the standard routing engine. So they're no longer intimately tied to the encryption and connection process in IPsec. You should know then the objects you need to configure to make a route-based VPN. A large number of them are in common with policy-based VPN, but there are those few additional objects that need to be created, like the tunnel interface. You should understand the difference between using an unnumbered and an addressed tunnel interface. You should understand the difference in how proxy ID settings are handled in a route-based VPN as opposed to a policy VPN. And you should understand how VPN monitoring will allow you to keep your tunnel up and operational, and the parameters that are settable in a VPN monitor. And finally, you should be aware of the tools that are there to troubleshoot route-based VPN. There are no new tools there. All of the tools that you have to troubleshoot a policy VPN also apply to a route VPN, and all of the tools to troubleshoot routing, and all the tools to troubleshoot policies, because route-based VPN is using the routing engine and the policy engine, so there's no difference in troubleshooting then routing and policy across a route-based VPN. And the VPN itself is still a VPN, so you need to get through your phase 1 and your phase 2 negotiations and create your tunnel. So you need to know how to troubleshoot those. So in terms of our verification operations here, there's nothing new. These are the same tools that we've seen in the routing lesson, the policy lesson, and the policy-based VPN lesson. If you have any questions about the material in this session, feel free to post comments, expansions, questions in the forum for the class. If you're not comfortable discussing things in public, you by all means feel free to contact me privately via the contact information on the course website. And I thank you for your kind attention to this session on how to configure route-based VPNs using the ScreenOS software on the Juniper firewalls.